Okay. So LeChatlier's principle, in the reference handbook, there's like a small paragraph devoted to LeChatlier's principle, and it's actually in the section 3.55, but it is asked as part of the kinetics questions, and we're going to go through a few questions, example questions of what they can ask you. But I'm not a fan of what they show in the reference handbook. It's very brief. It's a brief explanation of how LeChatlier's principle works, but we're going to go through a few slides here, so hopefully this is familiar for you. If you're looking at the reversible reaction, and this principle only applies to a reversible reaction. Based on a stress change or something that is added or removed to the system, what happens is your equilibrium shifts, meaning that stress causes the equilibrium state to no longer be in equilibrium. So you have to do something to counteract that stress or change to bring the system back into equilibrium. So when we're looking at concentration changes, if you increase the reactants, so in this case it's A and B, or A or B, or A and or B, when you increase this reactants, you're no longer in equilibrium, and the way you can get back into equilibrium is the forward reaction needs to be favored. You need to form more products. So in this case, when you increase the reactants, the reaction favors the products and moves to the right, meaning the forward direction is the dominant reaction to try to bring it back into equilibrium. Now, when you decrease reactants here, what you have to do is you need more of the products to form reactants. So the reaction shifts to the left because you want the reverse reaction to be dominant here. So it should move right to left to counteract that change. And when you increase the products, same thing. You're increasing these products here. So you need to move to the left to counteract that change because you have more products. If you're decreasing C and D, these products, you need to form more products. So the forward reaction is favored. So the reaction needs to shift to the right to counteract that change. Everyone get that? Maybe I went too fast, but just if you can just let me know in the chat if it's okay. Okay. So that's concentration changes. Yeah, it's you first learned this in high school and it's on your PE exam. So if you remember this from high school or even college, it's good to know. Yeah, David took the words out of my mouth. It's a easy question, but if you've never seen it before, it becomes more complicated. Now, when we're looking at temperature changes, let's say you have an endothermic reaction. So if it's an endothermic reaction, right, where would the heat term be in this general reaction? Would it be on the left or on the right? Yeah, so it's on the left because standard convention is the reactants are on the left, even for a reversible reaction. So if the heat term is on this side, for an endothermic reaction, if I increase the temperature, I'm adding heat to this side. So that shifts the equation out of equilibrium. So to counteract that change, the reaction needs to move to the right. You need to form more products. Now, if I decrease the temperature in an endothermic reaction, I'm lowering the amount of heat here that was originally there when it was in equilibrium. So that also shifts the system out of equilibrium. So to counteract that change and get back into equilibrium, the reaction needs to shift to the left. So the reverse reaction is favored.